This talk is all about adaptation, different forms of visual adaptation, and how you accomplish that in Flutter. First, we're going to look at some new components and new APIs for adapting your app for your brand. Then, we'll look at how Flutter adapts for iOS. Finally, we'll explore how to use Flutter and material design to adapt beyond mobile, including a sneak peek at some experimental design guidelines for emerging trends in app design.
At the last I/O, we released tools and APIs for adapting your app to your brand and customizing its look and feel to differentiate it from other apps. We call this material theming.
Before material theming, there was pretty much one look to all material apps. Sure, maybe people changed up their app bar color, but that was usually about it. They all looked the same.
Even though we always intended material to be flexible and extensible, we realized we didn't spend enough time in our guidelines explaining how you could do that. But now we have.
Now, when you look at a component or subsystem in the material guidelines, you'll see how it can be easily customized to be unique. And we started with our own apps. Here at Google, we came up with a custom material theme that expresses our brand. You probably noticed that throughout 2018, a lot of Google apps released updated designs that are more rounded, built from white, and use our custom fonts for headlines.
People have asked if they're supposed to make their apps look like this now. Not exactly. Now we've given you ways to make sure your app has its own unique style that incorporates the typography, colors, and shapes of your brand. This will help it stand out from the crowd and help users build a connection to your app specifically.
As we've said before, doing this in Flutter is easy because Flutter has great support for material theming. We've been busy expanding which widgets you can customize with theming. We now have dedicated theming classes for app bars, buttons, cards, chips, tabs, and many more. These theme classes are great. You specify them once, and then every component instance will inherit it.
Material theming introduced really cool guidance on using shapes to customize your UI. And now even more of these themes support those corner treatments.
Many components can use a custom border object for rounded or cut corners in their dedicated theme classes. For example, notice how card theme has a shape field that takes a border. And so does dialog theme.
Speaking of theming, does anyone here like dark mode? Yeah. Well, you'll be happy to hear that, yes, this year Material Design is releasing much requested guidance on dark mode theming. And I think it's gorgeous.
To implement a dark theme in Flutter, use the dark theme field on the Material app. That way, when the OS toggles dark mode, your app will automatically switch between light and dark themes. And if you need to check that toggle manually, you can always read the platform brightness property on Media Query. For more information on adding dark theme support to your designs, see the session, How to Design a Dark Theme Using Material, on Thursday morning.
The material library is constantly improving, and we've been working hard on making customization easier, not just in the themes, but in the widgets themselves. So let's quickly do an overview of the new features and material components in case you missed it. They can help you implement a unique material theme for your app. Now, sliders have an even wider API for customization, making it easy to create controls that were almost impossible before. Let's take a minute at how to use these new APIs to create a custom slider. Code demo? Now, last year, I hit a wrong button on the live coding, and it broke. So I'm going to let Anthony do it all this year. Anthony?
I got it. OK, so right now we've started with just a blank scaffold, but we're going to add a slider to it. And then we're going to do a radical customization of that slider using a slider theme. So first, to implement my slider, I need a value for it. And I'll set the initial value to 0.5, which would be right in the middle. Then I can go to my scaffold, which has a body, and create the slider. Slider has two mandatory required parameters. One is the value which I just made, which is used to tell where the thumb should paint on the track. And the other is the onChanged handler that we can use to update that value. So the onChanged handler takes in a new value, and I'm going to call setState to update the old value with the new value. So now, oops. Now I should have a material slider, and it works. But like we said, we want to make this thing look radical. So I already have these shapes down here where I've overridden the paint methods. I have a thumb and a track. So I'm going to add those to the slider. So first, I wrap it in a slider theme. So I use Alt-Enter in Android Studio, and it brings up this nice menu where I can wrap with a new widget. And I want to use a slider theme. And that takes in a slider theme data, which has all of the properties that I can override. So I'm going to set the track height to be really big, 48. And then I'm going to set the track shape to be that class that I just showed you, which is called Rainbow Triangular Track Shape. And then I'm going to set the thumb shape to be triangular. And after all that, I don't put a semicolon there. So after all that, there we go.
Oh.
We have a radically designed slider. And you can see how different this looks from the slider that we started with just by overriding these custom shapes.
Yes, that's very Pink Floyd. It reminds me of Dark Side of the Moon.
Yeah, it even syncs to Wizard of Oz. Black and white, color, then black and white again. So,
yeah, that's a thinker. Yeah. Thank you, Anthony. All right, back to the slides. One of the most requested features from the community was optional labels on bottom navigation bars. I'm happy to say that this has landed. Now your app can have the same navigation as Google Home and Instagram. We still recommend that you use labels for clarity and accessibility, so be sure to test with your audience to verify that they know how to use your app.
Another thing we've iterated on are floating action button transitions. We've made it easy to get a beautiful transition between two screens that have extended floating action buttons, where the fabs themselves animate during the transition.
We have some new widgets, too.
And some of these components are more advanced. And in other frameworks, you'd usually have to rely on a third-party library to get them, but not in Flutter.
Here we have a list view that can be reordered by dragging, called Reorderable List View. The animations are built in. Just set an onReorder callback to update your model when the user moves a cell.
And here we have a sneak peek at the new range slider. It's a slider with two thumbs for choosing a range of values instead of just one. It'll be in prod later this month.
Here's another component that's pretty new, expanding search bar. You can see that when the search bar is engaged, we can show historical searches and search suggestions as we type the query. Let's take a look at how we do all this in code.
First, create a class that extends the abstract class search delegate. Override the build suggestions and build results functions and return what you want to be shown. In our example, it's a list view for text, or a list view of text when the user is typing, and a grid view of images for the actual search results. Calling the show search function will open the search text field, and underneath it, the list view will return the build suggestions. Let's see how we do that in more detail.
Every search delegate has a query string. When it's empty, we return a list view populated with historical search queries. And when they've entered at least one character, it returns the strings that start with that query in a list view. For the results, we return a grid view with the correct images.
In addition to customizing the style of your app to express your brand, your app should also adapt to the needs of your audience. We've got a couple great new features that can help improve the accessibility of your experience for certain cases and some easy guidance for improving others. Accessibility features in Flutter are mainly accomplished with the Semantics library, which handles the semantics tree. Your app's semantics tree is like your app's widget tree, but instead of containing widgets, it contains semantic nodes that define the accessibility hierarchies passed to the operating system. So when you need to adjust accessibility experience, you'll probably just use an API with the word semantics in it.
There are some easy wins for improving accessibility. We're going to use a couple to show you how intuitive the semantics library is. The first thing is to make sure your UI has natural-sounding semantics labeling. People with visual impairments often use screen readers to reinterpret what's on the screen into sound or braille. But if it isn't given enough information, it could end up being a confusing experience. For example, if you ask the screen reader to inspect this widget, it would probably say 30 km/h. What we want it to say is 30 kilometers per hour.
No problem. Set the semantics label field on the text widget to say something clearer.
You can do this with icons, too, which is great because icons usually represent something other than their literal meaning.
And if you have a widget that doesn't have a semantics label field, wrap it in a semantics widget and set the label.
The second is the order the screen reader traverses your UI. Like here, we have 2 columns, each with 2 buttons, placed next to each other in a row. In left-to-right language locales, the screen reader will assume this was intended to be read like you'd read a book, left to right, line by line. Volume up, volume down, channel down.
But that's a confusing order for these controls. What we really want is volume up, volume down, channel up, channel down. So we wrap the buttons in semantics widgets and specify the order we want them to be read in.
While we're on the topic, color and contrast are vital to improving the accessibility of your UIs. When contrast is higher, all people, even those without impairment, have an easier time understanding your UI and using your app.
We've updated the contrast ratios in our selection controls, radio buttons, checkboxes, and switches to better incorporate recommendations from the Web Content Accessibility Guidelines 2.0. Contrast ratio is the luminance, or brightness, of a color compared to the color it's against. So here you can see that the check mark on the left is light purple. And when you compare its luminance to the white background, it's 2.41 to 1, which is below the WCAG guideline of 4.5 to 1. On the right, the darker purple measures 7.62 to 1 against the white background, which is much easier for many people to see.
We've also been increasing the touch targets in some of our components to be slightly bigger and therefore easier to hit.
We think that the ideal touch target size is 48 points by 48 points. So that's the default now on material buttons.
Finally, there's even some new accessibility test functions you can run during your widget tests that will tell you if your widgets pass these contrast ratio and tap target guidelines. You can find them in accessibility.dart in Flutter test.
OK, so far we've seen how to make your app more accessible to use existing and new material components to achieve polished style. So speaking of style and polish, Will, can I ask you a personal question?
Well, of course, Anthony.
Why do you always wear suits?
It's because I believe you don't dress for the job you have. You dress for the job you want. And the job I want is suit salesman.
Me too, Will. Me too.
Clearly.
Anyway, obviously Flutter makes it easy to get the same design deployed on multiple platforms. But what if you want your experience to be respectful of platform expectations? Well, for iOS, we have a special library.
Cupertino is Flutter's iOS design language widget library, and it has some new widgets too. Since the last I/O, we've added Action Sheet, Date Picker, Segmented Control, and more.
You probably know that for some things, getting the right design between Android and iOS is built in. Material has some specific behavior on iOS, and can even return Cupertino widgets if your app is running on iOS. For switch and slider, just choose the adaptive constructor, and the app will automatically choose either the material or Cupertino-based widgets for the operating system. This is a new paradigm we're experimenting with, and we'd love feedback on whether it works for you.
Being consistent but respectful between platforms is a great scalable way to scale your app design. But some of you, have told us that you're afraid using Flutter means that you're going to have an iOS app that looks like an Android app. Not true.
If you wanted to, you could have a radically different design when your app runs on iOS. You're never forced into one design for your apps. Just use the platform class to check if your widget tree is being built in iOS and return the widgets you'd prefer.
For more on how to use Flutter on iOS, watch the talk Building for iOS with Flutter tomorrow morning. There's also a great document outlining all the ways Flutter adapts for iOS at flutter.dev/adaptations.
We've given you a quick taste on how to adapt your UI to different operating systems. This is great because we can develop UIs for multiple platforms with minimal extra effort. But what about adapting beyond these platforms?
What does that even mean? Well, consider this. In the past, you only needed one design for your product, desktop. Then came mobile and tablet. Designers are accustomed to creating these experiences, and on web, everything in between.
But Flutter is the all-platform toolkit. What about when we go even smaller, like on a watch, or even bigger, like a TV? Now Flutter doesn't have official support for watches or TVs, but it's easy to experiment with them in Android Studio anyway. But we already do support foldable phones. How do you handle that?
Adaptive layout is how your app appropriately displays the UI best suited to the screen it's being viewed on. Historically, you might have built a separate app for each kind of device. But with Flutter, you can get all of it from a single code base. It's a concept we're beginning to consider as apps show up in more and more places for more purposes. So we have a sneak peek at some guidance for how to design it and how you might code it in Flutter.
Look for opportunities to design adaptive components. Adaptive components are discrete collections of shared elements, different ways of using the same atoms in different molecules.
It's worth mentioning that adaptive components are mainly a design concept, a way for designers to make multiple experiences from the same content. Depending on what they come up with, it may or may not make sense for you to build widgets that automatically adapt to all cases.
But when you do build them, do your best to avoid layout spaghetti. A simple rule of thumb is if only a few parameters change, like style or like text style or padding, then go ahead and wrap it with that logic in one widget.
But if there are structural layout differences, like one is a column and one is a stack, then you should make separate widgets to keep it simple and readable. But that's OK, because it's easy to make widgets in Flutter.
Consider this example. There are 9 cases for this adaptive component here. Which are good candidates for shared code? These 3 groups. The green ones are row-based, the blue ones are columns-based, and the red ones are stack-based. Each of them could be easily built as a configurable widget that handles those cases. And of course, they could all share the same data model.
Looking closely, these two have only a few minor differences between them. Text styles, the image scrims, and the column alignment. The one on the left has end main axis alignment, and the one on the right is centered. So you could make one widget that took a flag for determining those attributes.
You should also consider whether your app should have different experiences that depend on how you expect the user to interact with it. Imagine an app that has a TV experience and a desktop experience. From a size point of view, those overlap. A TV and a desktop monitor are pretty much the same kind of screen. What differs is how you interact with them. A desktop experience is highly interactive with many controls.
A TV experience is leaner. It's not expected to be interacted with much, and sometimes not at all. We call this a passive experience. Every experience falls somewhere between completely passive and highly interactive.
Passive UIs are popping up in more places. Besides TV, you might have a countertop device in your home or a dashboard in your office. Even a smartwatch, when it's not being interacted with, gives a passive display of the time. There's a good chance your app could use a more passive version someday.
So how do you adjust your UI for more passive purpose, like TV?
Start by reducing busyness, putting less content on the screen. You want to make sure it can be understood at a glance.
Then consider the general presentation. You can see that on the mobile version, it makes sense to have a list with vertical scrolling. Now it might make sense to have cards that horizontally scroll. And do you need to show hover states so users know what they're selecting with the remote? Then consider text. If every device were held close to the face, one type scale would probably be enough. But in reality, highly interactive experiences like desktop and mobile are usually 1 to 3 feet from the eyes of the user, and passive experiences are further, usually 3 to 10 feet. So body text that's readable on a phone isn't going to be readable from 10 feet away. Not to mention, it'll have the wrong feeling of scale. You may need relative sizing applied to your type scale, so your text is legible in all contexts.
There are a couple simple ways to do this in Flutter. To increase the size of your text globally, you can add a transition builder to your material app. Read the media query from the build context and multiply its text scale factor. The builder will apply this to the text in all of your routes. Just be sure to take the existing text scale factor into account in case the user has changed the default font sizes in their accessibility settings.
You can also return a different text theme if you want different weights or sizes applied in different versions. Just do that when you build your theme. You'll want to make sure your different experiences also have the correct kind of navigation. For instance, your phone version might have a short app bar, and your tablet and web versions a regular app bar.
But your passive version could have no app bar. Doing this in Flutter isn't too hard. Just add a widget or not, depending on the expected use. Let's code an example app together now. We'll build parts of the material study Fortnightly, which is a hypothetical newspaper app, and we'll see how we can make it look perfect on lots of different screens. Now, what we'll be showing you is just experiments, things Material and Flutter don't have official support for yet. But Material is always future-facing, and we believe that since Flutter is so flexible technically, it makes the most sense to do our experiments on it. So what I have here now is a hypothetical example of creating one app that supports many different screen sizes. We have countertop, foldable, TV, and wristwatch. So it's simply a switch statement that returns a different widget depending on which screen size, which device type we're in.
Now, that's just an enum you made yourself, right?
Yes. So I've left the foldable unimplemented because I want to implement that here together. It's a little bit different because the foldable phone itself has 2 or more layouts. So to do that, we're going to use a class called Layout Builder. And again, I can hit Alt-Enter here, and it will add in the argument automatically for me. So you can see a Layout Builder is just a widget builder, but it comes with box constraints. We can use these box constraints to find out the max width and max height that this widget will take up, and then we can do something depending on its aspect ratio. So first, to pull out its max width and max height, I'm going to call constraints.biggest, which is the max. And then to compute the aspect ratio, this should be final because I'm only using it. It's not going to be redeclared. To compute the aspect ratio, I will divide the width by the height. So now that I have the aspect ratio, I can do if the aspect ratio is less than what our designers have chosen to be 0.7, I'll return the fortnightly phone portrait. Else, I'll return fortnightly foldable open. So that's pretty much how you would implement that, and we're going to show it to you live right now.
All right, so this is a good use for the foldable phone. So you can see here is the first version of it. Skinny, and it does that. And then when we open it up, it reveals a lot more information. Again, with all the things, navigation on the left, instead of inside the hamburger menu.
Cool. Thank you. So that was foldable phone. What about TV? Well, we don't have a TV here, but I do have the Android emulator TV with a version of Fortnightly on it.
Now, those widgets that we're looking at there in the carts, is that reused code?
Yes. These widgets are actually in every single widget except for the smartwatch, because that one's a stack.
So you're reusing this widget in all the different versions that you're using?
Correct.
Awesome. And so, again, what's the extreme away from TV? Watch. And we were able to do a little hacking and get things running also on the watch. There it is. It's the same code base, the same app, running on many different devices.
Cool. So I'll show you that code where we were reusing the same widget for all the different article previews in all the different apps. It's right here. So you can see it's just a column of texts. But what's different, or what's configurable, is the width, the headline text style, because that changes on device, and then there's a flag here whether or not to show the snippet. On the TV version, we showed extra text because there's more space there. But on the phone, for example, we don't show that snippet. And that's accomplished by using this new syntax in Dart 2.2.2 that lets you put conditionals inside of collections. So this says if show snippet, then use the spread operator to insert these other widgets in here as well.
Awesome.
So there's one more that we haven't shown. We haven't shown countertop yet. So,
oh, right.
You want to show that?
Yeah. So we kind of have this idea that we're playing around with that a countertop device probably needs to switch between a passive experience and a highly interactive experience. When you're further away from it, it needs to have the larger text and be more passive. But then when you walk up to it, you might expect to interact with it more. So we used the Firebase MLKit library with Flutter to use the camera to see when I get closer by measuring the space between my eyes. And hopefully, if it works, it'll change between experiences. All right? It sees me. There you go. All right.
Cool.
Back to the slides. So a watch, a phone, a tablet, a TV. I think you've seen in our experiments that Flutter is made to run anywhere.
But we really wanted to see what it could do. So we did a bigger experiment. Let's take a look at where else we got our newspaper app running. What you just saw was Flutter running on the AnyPixel wall in the lobby of Google NYC. And we'll be releasing the code for those demos at a later date.
So, as I'm sure you've guessed today, we're very excited to announce that Flutter has full wall support. Just kidding. But I think you get what we're saying here. Flutter has arrived, and it has arrived everywhere, from phones to the web, and even digital art installations. And material design is your key to adapting to this varied world.
So let's recap. What did we cover today? We went over what's new in the material library, from theming to accessibility to brand new components.
We showed how it can easily adapt to look more appropriate on iOS.
And we looked into the future of app design to see how only one code base is needed to run on devices, from watches to digital art installations and button walls.
Be sure to check out the other Flutter talks this year. They cover building in iOS, Chrome OS, and the web, what's so awesome about the Dart language, and how to structure a real app state management.
And other material design talks. They cover our new guidance for dark mode, machine learning, sound design, and lots more.
If you're here at I/O, be sure to sign up for office hours with us. Flutters are tomorrow morning, and material components for all the platforms are tomorrow afternoon and Friday morning.
And all week, you can stop by the sandbox. Come to the Material Design and Accessibility Sandbox for app reviews with the material designers, and to the Flutter booth for fun and games, swag, and a chance to see Will in street clothes.
No promises. Anyway, I'm Will Larche.
And I'm Anthony Robledo.
Thank you.